Welcome to Geomega Virtual Learning. In today's presentation, we'll be talking about volume of pyramids, cones, and frustum. We will go through the formula for calculating volume of pyramids and cones and extend our knowledge from cones and pyramids to talk about frustum, and then look at an exam-style question. Definition of pyramid could be given as pyramid is a solid with polygonal base, and each base edge forms a triangle with apex. What this means is that these are examples of pyramids, and they all have a polygonal base: square, square, triangle, pentagon. And apart from the base, which is a pentagon, they should all have identical triangles around it. That's what this definition is about. You should have triangles around it with a base. It could be triangle, could be a square, could be any of the polygons. A cone is a solid with a circular base and a single vertex. That is also an example of a cone. Now, we call this oblique, we call this right simply because the height is in the exact center of the base, height not in the exact center. The same for this one. So when the height is in the exact center, we call it a right cone, right pyramid. Oblique cone, oblique pyramid. Now I'm going to take you through some sort of pictorial proof of the origin of volume of a pyramid. So I have a cube 4 by 4 by 4 centimeters, and I'm putting through the 4 longest diagonal, 1, 2, 3, 4. And I'm going to shade a pyramid. So you could see that I've shaded a pyramid with the base 4 by 4, and the pyramid goes up to the very center of the cube. Now, looking at this cube, can you sort of guess how many of such pyramid could be used to completely make the cube? Remember, a cube has 6 faces, and I form a pyramid on one of the faces. If you guess right, the answer is 6, which means I could form a pyramid on each of the faces. Okay, now, so we are saying that the pyramid is a sixth of the volume of the cube. Meanwhile, the volume of the cube is 4 by 4 by 4, which is 64 centimeter cube. So if the volume of the cube is 64 centimeter cube, and the pyramid is a sixth of the cube, then we can say the pyramid is 32/3 in simplest form. I don't want to go into decimal, so I'm just keeping it as a fraction because I'm going to make a reference to this fraction to prove a point. So the volume of the pyramid is 32/3 centimeter cube. Now I'm going to slice the cube through the middle horizontally. So I've done that such that the pyramid will fit perfectly into the new shape. Let's pull it down. So you now see that I have a cuboid this time, 4 by 4 by 2, and the pyramid sits perfectly inside this cuboid. Remember, we said 6 of the pyramid makes the cube. This time, slicing half of it. How many of the green pyramid makes the cuboid? It should be 3. Okay, so we have 3 of the pyramid making the cuboid. Volume of the cuboid is 4 by 4 by 2, 32 centimeter cube. And if the pyramid is a third of the cuboid, we can say that the volume of the pyramid again is 32/3, the one we had in the previous slide. Now the difference here is that we can see that this time the pyramid fits perfectly inside the cuboid. So therefore we can deduce from here that pyramid, the formula is simply the volume of the prism that it fits in divided by 3. So the volume of a pyramid is a third of the prism that it fits in. That is why the formula for pyramid is base area times the height divided by 3. That's a little proof. There are complex proof, but this is the little proof that I can use to explain to you why the formula is base area times height divided by 3 for pyramid. And we do the same for cones. We imagine it as a cylinder, we work out the cylinder, and we divide it by 3. Now let's look at examples. Area of base times height divided by 3 is for pyramid. Area of base, which is pi r squared, times height divided by 3. So imagine it fits inside a cylinder. That's the prism that a cone fits in. So an example, area of base times the height, then we divide by 3, that will give us 40 cm cube. 5 times 4 is the base, height times by 6 divided by 3. Same for the pyramid, the cone, area of the base is pi r squared, then times it by 8. Pi 5 squared times it by 8 divided by 3. When you work it out, it gives you 209.44 cm cube to 2 decimal places. So this is what I need you to remember. Cone fits inside a cylinder, so the volume of a cylinder divided by 3. A pyramid fits inside a prism, could be a cuboid depending upon the base of the pyramid. If it is a triangular base, then it fits inside a triangular prism. So you work at a triangular prism divided by 3. If it fits inside a cuboid, work out a cuboid divided by 3. Now try this yourself. Okay, let's check the answer. Base area 4 times 6 times by the height and divide by 3. Base is 24 times it by the height divided by 3 is 56 cm cube. Note, the base is a triangle. So you find the base, 5 times 9 divided by 2. That is 22.5 meters squared times it by the height, 90 meter cube. So you need to always check the base. Check the base. Cone. Also try it yourself. Let's check out the answer. So you imagine this is a cylinder, base area times it by the height, then divide by 3. We are talking about perpendicular height, not a slant. Perpendicular height. So base area, pi times 7 squared, times by the height, times by 7.14, divide by 3. That gives you 366.37 cm cube. Next one, same. Pi times 5 squared is area of circle, times it by the height, times it by 12. Then you divide by 3. Simplifies as 314.16 cm cube to the decimal place. Now, what if we have a situation where the perpendicular height is not given? The formula is still area of base times height divided by 3. Now look at this. There are two questions. They are not the same. They look similar. The 10 that you see here is the 10, the height of actually the triangle. This 10. The 10 that you see here is the slant height of the pyramid. So they are not the same. So this 10 is not the same as this 10. You need to be very careful. So let's look at the first one. We're going to use Pythagoras to find out the perpendicular height. If that is 12, from this center to this side has to be 6. So we have 10 as the hypotenuse and 6 using Pythagoras, the subtraction rule, to work out the height. So it's 10 squared minus 6 squared, square root of that will give you 8. So we now know that the height is 8. So therefore go back to the formula. Area of base is 12 times 12 times it by the height. Height is 8 and divide by 3. So it's 384 cm cube. So you use Pythagoras to find out the height first before you use the formula. Let's look at question 2. Now that's a bit tricky. So you must first work out, use 12 and 12 to work out the hypotenuse of that. So using Pythagoras, that will give us 12 root 2 cm. Now I'm going to divide 12 root 2 by 2 such that I can make a perpendicular height to form a right angle triangle with a 10. I'm trying to make a perpendicular height with this line and form a right angle with a 10. So divide 12 root 2 by 2. Okay, so you see I've now formed a perpendicular height, and the yellow and the green and the blue makes a right angle triangle. The green is half of 12 root 2. So half of 12 root 2 is 6 root 2, and I'm using the subtraction rule. 10 is the hypotenuse, so 10 squared minus 6 root 2 all squared. Square root of that will give us 2 root 7. So our yellow height is 12 root 7. I can now go back to the area of base, which is 12 times 12, times it by the height, 2 root 7, then divide the whole thing by 3. And that will give me 254 centimeter cube, rounded to the nearest whole. So know the difference between these two questions. This way you can create right angle triangles straight away. This way you need to make the diagonal at the bottom first. Divide that diagonal into 2, half it, form a right angle triangle with the perpendicular height, and use the subtraction rule of Pythagoras to work out your height before you use the formula. So know the difference between the two questions. They look similar, but the approach is different. Okay, here I have a cone, but the height is not given. I've been given rather the radius and the slant height. But I could see that I could make a right angle triangle and also use Pythagoras to find my perpendicular height. Remember, the height is always perpendicular height. So using Pythagoras, you're going to have 17 squared minus 8 squared. Find square root of that. Height is now 15. So formula is area of base, which is pi r squared, pi h squared, times it by the height, which is now 15, divided by 3. We now have our answer 320 pi cm squared, which gives us 1005.3 centimeter cube. So this introduction, linking Pythagoras into volume. Frustum. What is a frustum? A frustum is the portion of a cone or a pyramid that remains after the top is chopped off by a plane parallel to the base. I have a cone and a pyramid. I'm going to chop off the top. See that the plane cut off. Whatever it remains is the frustum. That's what the definition is talking about. We had the original shape. We cut off by a plane parallel to the base. So that's the plane parallel to the base. Chop it off. Whatever remains, that is our frustum. So you could have a frustum from a pyramid and a frustum from a cone. Now, to work out frustum from a cone is simple. It's like having two cones. The original cone and the small cone that you chopped off. So it's simple. All you need to do is work out the volume of the original cone, work out the cone that you chopped off, and subtract the cone that you chopped off from the original cone. The same for the pyramid. Work out the pyramid of the original, the volume of the original pyramid. Work out the volume of the chopped off pyramid, and take off the answer of the chopped off pyramid from the original cone. So that's what you see. The same formula. But you see that I'll use big R for the original one, big H for the original cone, small r from the chopped off cone, small h from the chopped off cone. The same big letters for the original pyramid, small letters from the chopped off pyramid. So this one, we have the original cone has a height of 9, radius is 7. The small cone has a height of the gap between 9 and 4. So you need to work this out. So we start. This chopped off cone has a height of 5. We got that from 9 minus 4. The radius of this chopped off cone is 3. So now we put into the formula, then we work it out, and final answer will give us 414.69 centimeter cube. So important thing is know your values. 9 is your height original, 7 is the radius original, 3 is the radius of the chopped off, 5 is the height of the chopped off. Then you slot it into the formula, and all divided by 3. You are done. Frustum of pyramid is same. 10 is height original, 7 is weight original, the other 7 is also length original. So 7, 7, 10 forms the original. 3, 3 forms the chopped off, and to find the height is the gap between 10 and 6. 10 minus 6 is 4. So once we know the values, slot them into the formula and divide everything by 3. And that gives us 151.33 cm cube. Work this out yourself. Let's check the answer. We work out the missing height of the chopped off. That is 6. Put the values into the formula. You should have 955.04 cm cube. Now, exam style. You are given a frustum and you need to work out the volume. So you need to imagine the original shape. So we try to complete the shape by extending the lines. So this is the original shape. And you realize that the chopped off height is not given. We need to work it out. We can use similar shapes to do that. So we pull it out. That forms a right angle triangle. We're not going to use Pythagoras yet. We're going to use similar shapes. Now you see that there are two triangles, the chopped off triangle and the original triangle. We can create two scale factors and equate them. First scale factor. If I divide this 6 radius by the second radius, that will give me a scale factor. If I divide the full height, the full height is 8 plus h, divided by the chopped height. That's also another scale factor. And these scale factors should be equal. So this radius, bigger radius over small radius, must be equal to bigger height over the small height. That's what I've just done. And now cross multiply. 6 times h is 6h. 4 times 8 plus h. Put 8 plus h into bracket and multiply by 4 and expand. That will give us 6h equals 32 plus 4h. Simple equation. Group all the h. You're going to have 2h equals 32. Divide through by 2. So we have the small h is what? 16. Therefore, the bigger h is 8 plus 16. So you need to be very careful. The 16 is for the small h, so the bigger h is 8 plus 16. That's why it's 24. Now that you know your small h and your bigger h, put them into the formula. So we have the formula. And work it out, and you will get 636.7 cm cube. 636.7 cm cube. Let's look at an exam question. We have a cylinder of solid material with a radius 8 cm and a height of 20 cm. Has a cone with the same radius and the height removed from it. So this cylinder is 20 cm, the height, and the radius is 8 cm. Then we sort of create a hole inside the cylinder. And the hole that we create is in the shape of a cone. And the cone also has a radius of 8 and a height of 20 cm. So after taking off that hollow cone out of the cylinder, we are supposed to work out the volume of the remaining material. Okay, so we start. the volume of the cylinder, the original cylinder, is pi r squared, which is the base, then times the height. So at the entire volume before we took the cone off is 1280 pi cm cube, 1280 pi cm cube. Let's work out the volume of the cylinder that we actually chopped off from the, or some we didn't chop off, we just create a hole inside the cylinder. That is also pi times 8 squared times 20, but divided by 3. So we have 1280 over 3 pi cm cube. So if you want to find out whatever is left, is the original answer minus the cone that we actually remove from the cylinder. So we subtract, and when we subtract, our answer will be 2,681 centimeter cube to the nearest unit. If you round out to the nearest unit, the volume of the remaining will be 2,681 cm cubed, 2681 centimeter cube, nearest unit. That will be the volume of the remaining material. And that brings us to the end of lesson 3, volume of cone, pyramid, and frustum. Look forward to lesson 4, volume of cone, volume of spheres and hemisphere. Next lesson, volume of spheres and hemisphere. Hit the notification button, subscribe, and share with your friends. Thank you for watching.